Let's talk about one of the most incredible systems on the entire planet, and you own it. It's a high-speed information network that connects your brain to, well, every single part of your body. In this explainer, we're going to break down just how this amazing internal highway works. I mean, really think about it for a second. You touch something hot, and your hand just yanks back instantly. You hear a song you love, and your foot just starts tapping on its own. How in the world do those messages travel from your senses to your brain and then back out to your muscles in literally the blink of an eye? Well, it's not magic. It's something even cooler. It's biology. Your entire body is crisscrossed with what you can imagine as a biological superhighway. It's this incredibly complex network of neural pathways, and it's carrying information at mind-boggling speeds. Okay, so before we map out the roads of this superhighway, we've got to talk about the vehicles. The cars, the trucks, the motorcycles, they're all called neurons. As you can see here, these are the fundamental messenger cells. They're the little couriers carrying all the electrical signals that make up your body's information. Pretty important, right? So, like any good highway, this one has traffic moving in two directions. First, let's take a look at the journey up, the traffic heading to the brain. This is all about how you feel things. All that sensory information coming from your body, touch, pain, temperature, all of it, that's the northbound traffic. It's all heading in one direction, straight up to command central, your brain. And of course, these northbound lanes have a proper scientific name. They're called ascending tracks. These are the specific neural pathways that carry all those sensory signals from your peripheral nerves, the ones way out in your arms, legs, and skin, and shoot them all the way up to your cerebral cortex. That's the main processing center of your brain. So let's trace the journey. Make it real. Imagine you touch a piece of ice. First, tiny receptors in your skin detect that cold. Bam! Step 2, that message is sent into a local peripheral nerve. Step 3, it merges onto the superhighway, that ascending tract in your spinal cord. And finally, step 4, it arrives at headquarters, the brain, where you actually perceive the sensation as cold. All of that in an instant. Okay, so that's all the data coming in. But what about the commands going out? Well, that brings us to the other direction of traffic, the journey down. This is how the brain tells the body what to actually do. This slide really breaks it down perfectly. Ascending pathways are all about feeling, information traveling to the brain. Descending pathways are all about doing, commands traveling from the brain. See? It's a beautiful, perfectly balanced two-way street. These southbound lanes are called, you guessed it, descending tracks. Their entire purpose is to carry motor signals, the orders, from the brain down to what are called lower motor neurons. You can think of these guys as the local delivery drivers. They take that final command directly to the specific muscle that needs to get moving. Let's trace this journey down. First, your brain makes a decision, I'm going to pick up that glass. Second, a signal is fired down a descending tract. Third, that signal gets handed off to a lower motor neuron waiting in your arm. This little handoff point, by the way, across a tiny gap, is called a synapse. And finally, action. That neuron tells your muscles to contract, and you grab the glass. Mission accomplished. Now, this highway isn't just simple northbound and southbound traffic. No. It also has these specialized express lanes for really high-priority information, like our senses. Let's look at one of the most fascinating examples, the auditory pathway. This is the express lane for hearing. The journey of sound is just wow. It's so incredibly precise. As you can see here, it all starts with these tiny receptors deep in your inner ear detecting vibrations. From there, the signal zips along a dedicated cranial nerve, enters the central nervous system for some quick processing, and finally arrives at the auditory cortex. That's the part of your brain that lets you consciously realize, oh, that's music, or hey, someone's calling my name. But here's the really wild part. This is happening on two levels at the exact same time. While your conscious mind is busy identifying the sound, a whole separate, unconscious pathway is also processing it. You know what that means? That's why a sudden loud noise makes you jump before you even know what you heard. It's your body's built-in reflex system, and it is way faster than your conscious thought. So, let's step back for a second and put all these pieces together. Let's look at the big picture of this incredible non-stop network you've got running. So to sum it all up, your body is run by this constant two-way flow of information. You've got the ascending tracks for feeling, the descending tracks for doing, and then you've got these awesome specialized routes for complex senses like hearing. This whole network, This is literally what connects you to the world around you. And just remember, this entire process, every single touch, every movement, every sound you hear, it all happens in milliseconds. The round trip from your toe to your brain and back again is faster than you can blink. So what does that tell you? The next time you effortlessly catch a ball or just walk across a room, take a moment to appreciate the sheer, unimaginable power of the biological machine that is you.